In this video, I'll discuss odd and even functions. The term odd and even functions describe the symmetry or the shape of functions. So there are three types of functions. Functions can either be even, odd, or neither. So most functions actually fall under the neither category. So we'll start with even functions. So we define even functions as functions which are symmetrical about the y-axis. So that is, if you have a graph, this graph will be symmetrical around that y-axis. So that means the y-axis acts as the vertical axis of symmetry. So as you can see here, this is a symmetrical graph, and with y acting as the axis of symmetry. We define even functions as functions that have their x value being equal to the negative of their x value when we substitute it into a function. So that is fx equals to f negative x. That just tells us that you should get the same answer for both positive and negative x when you input those numbers into your functions. We'll just do the algebra for this later on. We'll just start with defining all the different functions. So odd functions. So odd functions are functions which look like that they've been rotated 180 degrees about the origin. So this is y equals x cubed. So if I move this part of the graph 180 degrees, the other part of the graph would look like that. So we call this an odd function. So rotated 180 degrees about the origin, and odd functions are defined as f of negative x equal to the negative of fx. So functions which are neither do not fall under any of these categories. So neither functions are not symmetrical about the y-axis, and they don't look like they've been rotated 180 degrees. So some examples of neither functions are some linear graphs. Some linear graphs you can see do not look like they have an axis of symmetry, and they don't look like they've been rotated. Other neither functions can be exponential graphs. So polys, multiple degrees polys. So that's just a pictorial explanation of odd, even, and neither functions. Now let's define it using algebra. So scrolling down. So using algebra, even functions are defined as fx equal to f negative x. Odd functions are defined as f of negative x equal to the negative of fx. And neither functions are those that don't satisfy these two conditions. So like all math questions, it pays to be systematic with your working out. It just makes it easier for you to solve your problems, and it also makes it easier for markers to sort of mark you. So it makes it easier for me to mark your exams. So let's start with some examples. The examples that I'm actually going to use in this video are not the same ones we've used in class, but it still follows the same steps I've shown you in class. So let's do some questions. So a very common question is they'll tell you to state whether the following functions are odd, even, or neither. Alright, so our first example is fx equals to 3x squared plus 4. So since we already defined fx, we can move on to the next line. So once you've defined what fx is, the next step you should take is to find what f negative x is. So if we have f negative x, we substitute every x value with the negative x. So instead of x squared, I should have negative x squared. So 3 negative x squared plus 4. So negative x squared just becomes x squared, and times it by 3 gives you 3x squared plus 4. You can see here that 3x squared plus 4 is the same as the original function. So if our results are the same, then our functions, so our first part, which is this part here, are also the same. So we can say that fx equals to f negative x. So therefore, it's an even function. If I was to just draw a crude diagram of this sort of function, it would actually look like this. So it has a y-intercept at 4, and it's a very narrow parabola. But even if you were to test this graphically, and if you were to put it in all your graphing apps or GeoGebra, you can see that this is actually, in fact, a symmetrical graph, so it's an even function. So continue on to second question. So the second question is y equals to x cubed minus 4x. So what we should do is we should change the y into a function notation. So I'm going to replace y with fx. So now fx is 2x cubed minus 4x. So under the fx line, we should define what f negative x is. So f negative x is when I substitute x for negative x. And what you should get is 2 times negative x cubed, and negative 4 times negative x is plus 4x. So overall, it's just, sorry, it shouldn't be negative 2. Rub that out. So it's just 2 times negative x cubed, so that's negative 2x cubed plus 4x. We can see that this end product is not the same as the fx end product. So let's move on to our next one. So once you define what f negative x is and it doesn't work and the end product's not equal to fx, then move on to f negative of fx. So that's the negative of the whole function. So the negative of 2x cubed minus 4x. So negative 1 times 2 gives you negative 2x cubed. Negative 1 times 4x becomes positive 4x. And you can see that this end product here is the same as this end product. So this output's the same as this output. So therefore, its two functions, or the definitions of its two functions are equal. So f negative x is equal to the negative of fx, which tells me that it is odd, because that's the definition for odd functions. So scrolling down to get more space. Question C. Question C is y equals 2x cubed minus 2x squared. So once again, we don't have a definition for fx, so we substitute y with fx. And now we are going to define f negative x. So that's just substituting x for negative x. And you should get negative 2x cubed minus, 2x squared. Okay, so once you define what f negative x is, and the output does not look like the output of fx, you go ahead and you define the negative of fx. So that's just the negative of the original function. So that becomes negative 2x cubed plus 2x squared. And you can see that neither any of these, these three functions are not the same. So this function is neither odd or even. Neither odd or even. So that tells me that this graph is not symmetrical, and not rotated 180 degrees about the origin. So using these three examples, you can actually go ahead and do all the questions in exercise 8.3 in your Maths in Focus book. Once again, if you actually have any problems with the theory or the content, ask me in class and I'll go through it again. In the next video, I'll discuss domain and range, so just watch out for that video.